Assalamualaikum warahmatullahi wabarakatuh, and a very good day. We would like to look at the next tutorial on computer aided manufacturing, and this is the module that should be firstly drawn and then created by using CATIA part drawing, and then will be sent to CATIA machining, prismatic machining for the process of milling, pocketing, and also drilling. Again, this is the model with the dimension. So you have 20 radius here, 20 millimeter radius here, 40 millimeter radius for the big circle there, and then a pocket with the depth of 15, and the thickness of this part is 30, right? So 30, and the depth of the hole, which is through hole, of 30 millimeter. So the design is drawn here, and the material is aluminium with the total weight of 1.69 kilogram. We will start with the sketch of this material, and yeah, I've done the sketch. You could see it from here. So this sketch can be done quickly. So with this dimension 80, 40, and 40 here again, 20, 20, and my starting point is the center of position of this coordinate. And then after I exit the sketch, I pad it, and then create another sketch on this to create a pocket with a dimension of 20 millimeter, 40 millimeter, and 20 millimeter, and these two will be concentric. Yeah. And then after I exit the workbench, I select the pocket function here, pocket function, by using the sketch that I've defined earlier. So the definition of the sketch is this rectangle with a circular arc on both ends, and then I define the depth of pocket of 15 millimeter by clicking OK. Next, the same on the same surface, I create another pocket, which is for the drill hole. So I start with just a sketch here of a circle with a diameter of 10 or 20 millimeter diameter, and then this circle is also concentric with the concentricity with the outer circle, right? After I exit the sketch, I create the pocket, right? And the pocket is a true hole of 35 millimeter. So I can type the depth 35 millimeter by selecting dimension, or you can also use up to max, for example, and the next is the last surface, or you can also use up to plane, and then you select the plane of this plane. So you click OK, you will have the same result of the true hole. Okay, so after you have finished creating the material, you can now send the before that, after you have finished created the first part body, you have to insert a new body. Click the part 1, insert body, and you have this body 2. So in this body 2, I've already created it the same as before. This pad is just the size of the sketch is given here. So it is a square shape of 153 times 148. So this size is being created with uneven number. So maybe I can change it to something that is more size like this. maybe I want to have 152 only. 152 as the vertical axis, vertical dimension, and then 147 as the horizontal dimension. So I exit the thing and then just pad it. So in this case, I've already put it under transparency. So if not, you can go back to properties, graphic. If you, after you pad it, a whole solid, you have like this. So I change it by clicking on properties, or you can also using alternate enter button while this is selected, body 2 is selected, alternate enter, and under graphic you can then increase the transparency, click OK. So you have like this. And even to let people see my product, I want to change the part body, the first part body color. Okay, and then I go to alternate enter or properties, and the fill color I change to violet, right? Okay, so now with this drawing, make sure that you have show all the sketches that's available there, and don't put it under hide. So if it is hidden for automatically, you can just manually unhide it or show it by right clicking on the sketch and then click show. Like this, it is hidden, and click again, it is shown. Okay, so after you have this, and I also define a material here as aluminium, can go to the next process of machining, how to create this part. When you send this stock part or the raw material of a block shape to the milling machine, you can go to start machining, and you choose prismatic machining. Okay, so now you're inside the prismatic machining function. Here you have this process and part operation tree. So under this part operation 1, you double click on it, you will open a window, and here you have to select the machine. So the machine that you will be selecting is CNC 3-axis, and then don't forget, go to the numerical control, change the specific post processor to FANUC 0, and the post processor word table change to IMS PP table, and NC data type use ISO instead of APC standard. So ISO is matrix. Then click OK. After that, what you need to do is select the design part for the simulation, and the design part would be part body, or the first part that you have drafted just now. So double click on the part body. So if it is not working, just do it again. So until you have this link to the part body, and then you click on the stock or the raw material. It should be the body number 2, the second body. Double click on it, and you have all the links inside. After finishing doing that, you can just click OK to finish all the processes. Now you have defined the thing that you want to machine. Now what you need is to start with the machining process. So by creating the machining process, you have to click firstly the manufacturing program. Then of course we need to do facing first on top of the surface. So I use the facing operation, and the first surface that you have to click is the plane. So the top plane that you have to select will be the plane of this stock part or body 2, and the selection from this view is this small square. So you click on this small square first, and then as this body is still shown, not hidden, you just select on the top surface. After that, you have to hide body 2, click on this bigger square. So this will represent the surface of our product. So our product is this violet surface on top of it. and then you have to go to the selection of cutting tool. So you need to face it, so you have to choose face mill, and the diameter of a face mill should be yeah, this is standard. Actually you have different sizes. If in our lab you have 68, 62 millimeter diameter for example, but then you can leave it like this as a default, and then you can look at the toolpath replay by putting clicking on this button, toolpath replay. So wait for a while, and then you will see the tool is already being visualized here. So you click on this goes to start of toolpath or to previous operation, and you see it's moved to here and play forward. You'll see that is what the facing process will be done. Then click OK as you have agreed with the tool path that you have created just now. Then to make sure that your cutting tool will not collide with your workpiece during the machining, so you have to define the micromanagement here. So you have to firstly click on the approach, activate the button first, and then go down here, definition mode, change to axial, and then change it to, let's say, 50 millimeter, so that it has ample space between that. And then it goes the same for retract. You have to activate the retract first, change the definition to axial, and also double click on the 10 millimeter change it to 50 millimeter for example. Then you click OK as to finish the process, the first machining process. So you have here, when you open the tree here, manufacturing program 1, you have tool change number 1, which is the face mill of 50 millimeter, and the process is facing. So next, after you have done the facing process, you need to contour profile, or you have to remove the material of the bigger solid here. So to remove it, you have to hide it first. You have to choose profile contouring. Yeah, I forgot to make sure that it should be facing should be highlighted before you click on the process, because it will means that you have to do facing first. After then only you can do profile. Okay, so after you can just cancel it, show you again, click on facing, and then click on profile contouring. Okay, so you wait until the windows is open. Then the first thing that you have to do is look at this frame, and you see now you have two red color there, and you have, if I move the cursor to the first red on this profile, you see the wording there is click to select a guiding element. You see here, right click for additional selection methods. So you just click to select a guiding element, and our guiding element would be this line. So what you have to do, click on it first, then you have to decide which surface you have to start with. So I would like to choose the first surface to start is the, I think this one. Then start with this. So you have to follow the sequence. You cannot change direction. If not, you will actually damage the machine if you do it on the machine physically. Okay, after you have chosen all the lines, okay, you go to if you open this button for the first time, it will be appear down here. So you just put it up here, and then after you done that, you just click OK. So then you have that line as a guideline. Next, you see the next red color here as the lower surface or the bottom surface. Just click on this surface, and you need to select the bottom. So the bottom that you want to define is this bottom. So the bottom of this cutting surface. Alright, so you have highlighted all the colors there, and then just click the next thing you have to click is the selection of the cutting tool. So the last cutting tool you choose was face mill, and then you have to change to end mill, and this end mill has a size of 10 millimeter. So if you look at the drawing just now, it has a size of 40 millimeter here, and then the the bigger size is 150. So I think 10mm is enough, or if you think it is too small, you can change to 20. But then I think 10 is enough. So I can look at the toolpath replay by clicking on the button, and you see it start somewhere there. It's collided with the workpiece because I haven't set the macro definition yet. So I just want to look at the toolpath. So yeah, it looks good. Click OK, and then we need to go to the macro management, change the approach, activate the approach first, and change the definition to actual, and give it a number of 50, for example. And then for retract, also activate it. Go to axial and define it 50mm. And yeah, should set OK. Actually, you can also look at the video again if you want. Just double click on the file contouring just now, and then click on this toolpath replay. So you see now I have a different position of our tool, and if I look at this, so it will move like that. Okay, so next, the toolpath is also shown in this dotted line. Okay. Alright, so next, okay. Okay, before that, okay, let's do the next operation, which is pocketing. So by clicking on this profile contouring tool, you have to select the next process, which is pocketing. And now we have the next figure to select. So the guidance will be this first contour or first surface. So click on this, and then the surface should start with this white line on this pocket. So I start with this one, next, third, and fourth. So I have select all the lines that represent the pocket and click OK. And this is the bottom surface of our pocket. So just click OK on that. Then I have to define my end mill size. So the size that I have here is 10. I think I would like to change to 6, because I think it is appropriate, because the size of this pocket is bigger. And I think RC you don't need to change that first. Then you have to activate the approach, and also the retract. So you can yeah, you see. So with the size of 6, you can get very good feeder. So you look at the toolpath, it has a lot of more than one circular path. So you have 1, 2, 3, 4, 5, 6, means that all the surface will be swept over by this tool mill. So means that our cutting surface will be better. Okay, I click OK with that. Then the last machining should be drilling. So I want to have this surface being drilled, so I change to drilling, and the drill process will be this figure. So what you need to do firstly is click to add positions. So what you want to choose is this where is it? So double click on this line, okay, and then this diameter you change it to 35 as the depth of our model just now. Okay, and then you change to end mill, you change to the tool of drilling. So the drill diameter was 20, so you can also use 10. Let us look at the okay, if I use only 10, you have to change to 20 because the diameter was 20. Alright, then let us look at the process. So the process is just a 20mm diameter drill. If you want to look what happen if I choose 10, can do so. So from this simulation, it's only creating 10mm diameter. So let us put it as it is first. Built by user. Okay. So I think we have done all the processes that we required to create this model. And then what we need to do now is look at the process, the whole process again. So we can simulate it by clicking on manufacturing program, right click on it, go to the bottom of this window, and then you go to the start video simulation using toolpath. So just by clicking on it, you have this model. So I rearrange it, then I can just click on forward to look at what will happen after I create the machining. So you see this cutting diameter is 10, so the diameter of our hole is also only 10. So we need to change it to 20mm to get the bigger surface. Or you can also just add another drilling process to get the required diameter of the hole. So still we have this so pitch. This pitch is saying that we are doing roughing, and we should choose the correct toolpath to have a surface finish that is required. So just go back to this process, and I think you can add another drilling process with that. And then it change this to 35mm, and I change I have to reselect the size, and this one is 118. That is the common one, so I want to change it. Yeah, so I think that will be good. So to correct our profile, this is the pocketing. If I want to change the cutting tool and also the process, I change to toolpath style inward helical, back and forth. Okay, let me look at this first. So maybe we will have the ripples back in the middle, but we need to change to machine tolerance 0.05, fixture accuracy 0.05. So let us look at toolpath. I think this one should be better. So let us do the simulation again. Let's rearrange the thing and start. Okay, so you see something happen here. The definition of our contouring is too small, I think. Yeah, so it means that we didn't set the profile contouring. So means that during the contouring process, our cutting tool is eating or is feeding more than it is supposed to be. Alright, so we would like to check back on our contouring, and by default at this profile contouring, the cutting movement is given like this. So the direction of cut should be climb, so it means that we cut from small to big. So this is the correct cutting instead of conventional the big to small, or thick to thin. So that is not good for our cutting cutter to life. And the percentage overlap is 50%. And then yes, we have set the guiding element, which is the contour line out there, and then the bottom part here. And next, what we could check is also the offset contour. So the offset should be 0, and then the cutting tool I've selected is 10mm diameter of cutter, and then this is the holder. So I change the holder to 10mm so that we can have a cylindrical tool, so that we can see clearly when I put it in this normal plane, and the cutter radius is 0. So I would like to see what the tool path it generates from this motion. Yeah, I also did forgot to tell about one thing, and that is okay. So firstly, I would like to check whether this cutting tool colliding or not with the surface. So it looks like nothing happened. I mean, no collision, so it is good. So the another thing that I haven't told just now is to have a finishing process. So I set a finishing process, so by default it is put as no finish pass. So what is finish pass? So I want to set the first several cutting process was roughing. So from what we have done just now, we only define a roughing for one step with depth of cut about one way only. So no definition of cutting diameter yeah, maximum depth of cut, and we only have a number of levels, 1. So if you want to change it, maximum depth of cut, we can change it here. So maximum depth of cut is 0.5, so we can also define this. And then lastly, we need to select side finish last level. So we can click on this arrow, this question mark, to see what is actually meant by this side finish last level. And then if you want to look at the contouring, the process, so you see this is what will happen with the depth of cut of 0.5mm, and the last step will be the finishing, right? Sequencing, I'll do first. So okay, and then we select so the approach is also already been set. Okay, and then last, for the tool path of cutting, just now I set for default machining tool path, and I changed it to, so it was outward helical or inward helical, so I changed to back and forth, or we can also set a zigzag, so that we can make sure that all the surface is being passed through by the cutting tool. So if you want to look at this, and also we can set side finish last level, and then the side finish thickness is 0.01, for example, and we or side finish level, you can look at there. So this is the thickness of side finish path by level. So you can check to 1, and this is the side finish thickness of 0.01. Okay, and then termination radius. Okay, this is all as mentioning. Number of levels. So if you want to distance between path, if you want to change this, you will have to look at this. This is to set the between two distance of tool peak, tool center. So this is the the level, or this is what also we meant by feet. So if one to change that, or you can also use tool diameter ratio. It will be automatically set with the percentage of tool diameter 50%. On overhang is being set 50. Alright, and then so for this tolerance, I want to change it to 0.01, and I'd like to look at what type of cutting path it will create. So if I simulate this, you can see, so the motion is there, and so the machine time written here is incorrect because of our process output. We have to click on the camera picture. We can see so we have a very smooth surface on this plane, and only the surface up here is looking not very smooth. So there is another method of how to finish that surface as smooth as possible. And then so that's actually we need to have another operation by using contouring. Okay, so with that, I think we can start our machining operation. For drilling, we also need to check back. So I put two drill bit here. So the first drill bit should be 10mm in diameter. Alright, so I change this also to 10 so that you can look at this clearly. So that so this is approach clearance, which is this distance 1mm, and this is all set as standard. If you look at the machining, so if if we haven't set the cutting, so we can just click on this point and then double click on the hole that we have created, and it will automatically create the distance of the depth and also the hole diameter. So the hole is already set at 20, but then the depth was 35. In my drawing it was 30, so I think this one is having a different thickness as from what I've drawn just now. So this is from another part drawing, but it's okay, just leave it there. And then we could also check the simulation. So if you want to look at this, okay, so with this cutter diameter of 10, you can only get a 10mm diameter hole without a 20mm hole. I think if I'm not mistaken, the thickness is correct, 30, not what I said just now. Yeah, the 35 created was for to make sure that this hole is being produced thoroughly. So a true hole should be produced, not a hole with burr there. So because the definition of our hole is 30, so if we stick with the 30mm distance of drilling, it will create some leftover, which is the distance B, for example, breakthrough. So we can also change this drill diameter. Instead of changing the depth here, we can also do it somewhere here, but then I have this set at this distance, so we can leave it like that. Okay, and then we change with the second drilling process. Again, this one I didn't change anything, I just put it like that. And the next one is the same, yeah, 2 points. I think this one, so this one was set at 35, and this should be true. Yeah, okay, so click preview and let's see what it will create as a hole. Okay, so the hole was not created thoroughly, so there's some leftover of burr there. I think this is due to the fact that we created, we used this type of diameter and a length of 50 millimeter. So I think should change this number. This is what happened. I have to center it. Yeah, T6, T spot. It should be T20. Okay, D20, and then this one should be 20. So the length is 50 millimeter, and the ID here is 5.774. So this is the reason why 35 is not enough. So we need to add another 5 millimeter there. So we have to have 40 millimeter, 40 millimeter to get a complete through hole of hood. So let us look at the product. Oh, sorry. Okay, now we have a through hole, a complete through hole of preload. Okay. So with that, I think we can finish our cutting and look back at the simulation. Sorry. Alright, so we have the finished product. It should produce what we have said. Okay, another thing that I forgot to tell is that for profile contouring, I also mentioned just now, I changed this cutter radius to 0 in order to get smooth burr down here, or no burr at all. And then lastly, I didn't define a finishing process for facing, so we can also do that. So machining, we go to machining. So finish bottom only, bottom finish thickness, let's say 2.1. So we can look at this. So the difference will be seen in our simulation, and also the G code at the end of the starts. Okay, so with that, we could already produce our G code. So where do we want to create a G code? From here, manufacturing program, right click, go to manufacturing program 1 object. Down there you can select generate NC code interactively. Okay, in order to let this happen, you have to define what I've shown in the first second of this video. You have to select the options in machining, output, IMS, and it goes like this. Okay, so manufacturing object, generate NC code interactively, and then you select NC code and select the output folder where you want to have it. Okay, so in this example, I want to save it as a tutorial video and then I just click execute. So for a program number, you can select any number that I want. So it should just created. Wait, should be created. Okay, it should be down here, and the code should be written under cat and C data. So now we have this program written with 128 lines. Yeah, 128 lines. So we can check line by line, so whether this is appropriate for our machining, to be sent to our machining center. Okay, so with that I conclude the class. Thank you very much, and see you soon. Bye bye.